Hello everyone, I'm Chang from Peking University. Today I'm excited to present our research on Deus Ex Machina and personas from large language models, investigating the composition of AI-generated persona descriptions. We have 6 authors from 5 different universities across the world, and I'm the second author, Chang Liu. Our study delves into the world of user experience design, where personas play a crucial role in understanding user needs, behaviors, and preferences. This is the outline of our presentation, so I will introduce them one by one. First, about the background of our research. Personas are fictional representations of target users, traditionally crafted through meticulous research and analysis. However, with the advent of large language models like GPT-4, we now have the potential to automate this process while maintaining the narrative realism that makes personas so valuable. So, persona descriptions mainly consist of textual information about the user type and persona represents. Large language models generate personas based on prompts that describe the target user group, their needs, goals, and preferences, which hold promise for further automating persona generation processes, while being able to maintain the narrative realism of manually crafted personas. However, what are such personas like? Are they diverse in their representation of people? Do they contain skewness or bias towards certain characteristics? Are the large language model generated personas at all of satisfactory quality? How do stakeholders feel about them? These are some of the motivating questions behind our study. So our study aims to answer 2 primary research questions. First, how diverse are the characteristics of persona created by large language models? Are there any notable biases? Second, how do user experience researchers and subject matter experts, we call that SMEs, assess the large language model generated personas? To answer these questions, we first need to have a review of literature. Large language models have been explored in the design process in conjunction with personas in various ways, but there's currently very few studies similar to ours. Here we summarize the main previous work. For example, Pandey et al. Studied the anthropomorphizing of large language models. For instance, telling a large language model to talk like a doctor allows it to assume the role of a doctor. The researchers discuss an example of how different personas assigned to the same AI system led to varied behaviors. Polly illustrates that large language models can create user personas based on thematic analysis of semi-structured interviews with real users. Kokabali reported the capacity of ChatGPT to generate fictional user personas for a given project, for which ChatGPT was asked to generate 5 different user personas. Elisa and Al-Halifa created elderly personas from different demographic backgrounds that interacted with a conversational agent based on the persona's details. Hong et al. Illustrated the potential of large language models for assuming the role of persona by responding to users' natural language queries. Chang et al. Presented a framework named marked personas that applied natural language prompts to generate personas. However, none of these previous studies, as far as we know, have specifically investigated the characteristic of large language model generated personas in terms of diversity and bias. Also, we could not locate a study that would have tested subject matter experts' perception of large language model generated personas. So, this is how we conducted our research. As the research context, we chose a serious domain, addiction. Our choice was based on the notion that personas could be more broadly applied for social good, that is, societally beneficial purposes. So, in our study, the personas represented individuals with various types of addiction, including alcohol, opioids, social media, online shopping, and gambling. Addictions could be broadly characterized into 2 types: substance use disorders and behavioral addictions. Examples of substance use disorders include opioid, nicotine, and alcohol use disorders, while behavioral addictions include but not limited to gambling, overeating. We created 3 types of prompts for each addiction: 1 specifying male gender, 1 specifying female gender, and 1 not specifying a gender at all. The reason for this is that, first, we could control and balance the number of each gender. Second, we plan to test the gender distribution when it is not specified. So, given that we have 5 addictions and 3 prompt types, that yields a combination of 15. However, generating only 15 personas would be susceptible to inherent randomness into the large language model generation process. To thoroughly evaluate large language model ability to generate personas consistently, we need to repeat the generation multiple times. Each time we obtain a different persona. We chose to repeat the generation 30 times for each of the 15 combinations, thus yielding 450 personas in total. In general, challenges with large language model generated persona is that inputting the same prompt multiple times while OpenAI API to GPT-4 yielded nearly identical personas, which might be a coaching issue. We address this issue via a two-stage prompt strategy. First, we ask the model to generate a list of 30 skeletal personas for each addiction prompt type combination. Skeletal in the sense they only contain basic information. This resulted in unique short persona descriptions that we then inputted back to the model, asking it to expand each persona description to create the full persona descriptions for analysis. So finally, we use GPT-4 2023, the June of 2023 version to generate a total of 450 personas. As for the evaluation protocol, the procedure of data coding and evaluation is divided into two stages. The first stage is the internal evaluation of the generated personas to gain a sanity check on their quality, within which 4 internal evaluators from our research team were involved. Each evaluated approximately 120 personas. The second stage is the subject matter experts evaluation of these personas performed by 5 public health personas professionals with domain expertise on addictions. Within this stage, only a subset of these personas were evaluated by these external evaluators. They all use a coding sheet applied to the extract information and assigned evaluation rating to these personas. This picture shows our coding scheme. The definition column includes instructions given to the evaluators. The criteria highlighted in the blue color, that is, the last 6 items of the table, were given both to the external and internal evaluators. The other criteria before that were coded only by internal evaluations. Here comes the results. First, with respect to research question 1, we first look at the age. The average age of the personas is 37 years old, and the age of persona is not normally distributed with lower peakedness and flatter tails. Next, we use the chi-square test to compare the frequencies of different addiction types between various age groups. We omit the age groups from 13 to 17 and 65 plus because only one observation were included. As shown on the right, the age group within the highest prevalence of gambling and alcohol was 55 to 64, and the age group with the highest prevalence for social media is 18 to 24. We also investigated which addiction type is most prevalent for each age group. As a face value, the variability in these addiction types seemed to make sense in terms of the younger age group being more addicted to social media than older age groups, while further comparison to census statistics at a population level is needed to establish the robustness of these differences. From these findings, we can summarize that the large language model has an opinion of what age group is typically addicted to what, but in absence of the baseline data, we cannot deduct if that opinion is factually correct. And then, speaking of gender, we found that when not specifying a persona's gender in the prompt, the large language model generated a perfectly even distributed of male and female personas, thus resulting in perfect gender parity. Moreover, we also verified whether the generated personas for which the gender was specified actually matched the specified, and there was no significantly different relationship between gender and addiction types. In terms of jobs, the generated personas were extremely versatile, with 200 unique jobs being used. However, there are still some stereotypes about gender. Male personas are more likely to be construction workers, software developers, and unemployed, and female personas are more likely to be nurses, event planners, and baristas. To carry out the thematic analysis identifying common themes or topics mentioned in the pain points, we extracted keywords from generated pain points, and regression modeling was carried out to predict each word frequency based on age, gender, and addiction type. The regression analysis for work showed a significant relationship with addiction types, but not the age or gender. Among these addiction types, gambling had the strongest negative relationship with work, followed by shopping and social media. In terms of the physical appearances, it was extremely rare that the large language model would emphasize physical appearance in the persona's descriptions it created, which means large language models does not consider physical appearance as a dominant descriptor in this context of persona creation. We can find that the large language model's viewpoint on individual is often positive. The persona is more portrayed as a protagonist than an antagonist. As for the text analysis, we found that the average length of large language model generated personas description was 380 words in general. This suggests a moderate amount of variability in the length. Second, we can see that there's no statistically significant difference in persona description length in terms of the word count between male and female persona descriptions. In terms of age, we found as age increases, persona descriptions tend to be shorter, but the strength of this relationship is relatively moderate. For the second research question, how do user experience researchers and subject matter experts assess the large language created personas? We first have qualitative results. We found that the average scores of the personas indicate a high degree of consistency, relatability, positivity, believability, and informativeness for design. In construct, stereotypicality is low. Second, we conducted a series of Welch's t-tests to assess whether the differences in the rating between the internal evaluators and SEMs were mixed, with some statistically significant differences for certain criteria. The results indicate that SEMs rated the personas more stereotypical, less positive, and less relatable. But both the quality scores given by SEMs and our internal evaluators indicate rather high than low quality personas. To better understand the scores given by the SEMs, we asked them to provide open-ended explanations regarding their answers for each evaluation criteria. Here, we summarize the main insights, including believability, relatability, consistency, informativeness for design, stereotypicality, positivity. You can read the paper for details. So here we conclude our study and have some discussion on the implications. To answer our research questions, we mainly have findings that our first research question deals with the diversity and biases of the large language generated personas. Overall, the personas generated by large language model appear diverse. They do contain some biases about the age, country, personality, occupation, and so on, but the source and severity of these biases are difficult to assess. Our research question 2 dealt with the internal and external evaluation of the personas. The results indicate that large language models can generate consistent personas that are perceived as believable, relatable, and informative for design while retaining a relatively low level of stereotyping as perceived by the human evaluators. We offer some tentative explanations for the observed bias. For example, the use bias might stem from the fact that machine learning database often overemphasize younger demographics. And second, the US centricity might have a similar background, stemming from the fact that many machine learning training sets were based on English materials. And we must bear in mind that OpenAI is a US-based company, which might further accentuate the lack of cultural adaptation to its model's behavior. Third, the large language model's positive outlook on each persona is likely due to OpenAI's guardrails on the output and corresponds to the observation made by other researchers. For the successful implication of large language model in the persona creation process, we propose the following guidance. First, we should verify the large language model generated personas using diversity and bias analysis techniques, such as those illustrated in this work. Second, we should verify the large language model generated personas using subject matter experts to establish external validity. Third, we should adjust the prompts if we observe challenges in diversity bias or quality of the personas. By following these guidance, persona creators can mitigate the challenges and risks associated with using large language models for persona generation. These findings have significant implications for the design community. They suggest that with careful prompt design and evaluation, large language models can be a powerful tool in persona creation. However, it is crucial to address these biases to ensure that the personas generated are representative of the diverse user groups we aim to users. In general, despite some biases, we conclude that large language models can generate consistent, believable, relatable, and informative personas for design purposes. The large language model generated personas hold promise for design and user research applications, providing a foundation for further research. This is our presentation. Thank you very much for your attention. We welcome any questions you may have on these fascinating topics. Please contact us through the email. Thank you.